All right, so here's what we're going to try to do. If you look at the worksheet, I'm going to do something slightly different. So take a look at the very first part of this, okay? And I'm going to go ahead and do this problem separately. I'm going to take the derivative of this. Actually, you know what? Go ahead and do the derivative yourself. I'll be doing it in parallel, and then when you get done, we'll check our answers, make sure we're all good. So, I would take the derivative of this. I would do the derivative of the outside, right? Throw the 3 out in front. Drop its power by 1 times the derivative of the inside, correct? Okay, so you throw the 3 out in front, like that. I get 3 times 1/3, and then I would get x squared plus 1 squared times 2x, and that would be my derivative. Agreed? Now, what the problem is what if I gave you an integral that looked like this? How do I do it? Okay, two things multiply together, and I have to use a product rule backwards. We know we don't know how to do that. So here's what we're going to do. We're going to guess. This is a chain rule, and we're going to guess what the chain is. Right? So the first thing I'm going to do is I got to decide what do I think is the ugliest part of this problem. And so I look in there and I see what's the ugliest part of this problem. It looks to me like it's the x squared plus 1 because that's a big mess. 2x looks much nicer to me. So I'm guessing. Now if you guess and you guess wrong, you just have to guess something else. So I'm going to say u is equal to x squared plus 1. Now I need to figure out where the 2x is, right? So if there is a chain, I need to take the derivative of the original function to figure out what the chain would be. So this becomes 2x, right? And so then for notation purposes, we're going to get rid of this 2x dx, right? This dx by multiplying both sides by dx. Just a notation thing, not to worry. Okay? Now I look up above here, and I look and I see, what do I have here? I have a 2x dx. That 2x dx is equal to du by our definition. Also, u is equal to x squared plus 1. So if I look at it carefully, I go, well, I can rewrite this whole thing as replacing the x squared plus 1 with u. I can write that as u squared, and I can replace the 2x dx, this whole thing right here, with du. When I get done with that, I raise this power by, now I integrate. Can I integrate this? Absolutely. It becomes u to the third over 3 plus c. Now I didn't have a u to begin with, so I'm going to put the u back in, and I get x squared plus 1 parentheses to the third power, right? I get a 1/3 out in front, and then I get a plus c. And so you know, we started with this, we got to here. By integrating backwards, we do this. Now, all this stuff amounts to one thing. We're guessing what this piece here is in the derivative. And we're saying, well, if that's the piece in the derivative, then I'd have to chain it, right? Now, when you're taking the derivative, you tack on the chain. You multiply on a chain. When you take the integral, I have to get rid of the chain. So this step right here, where I switch the du for the 2x dx, I'm getting rid of the chain that would appear. So I'm guessing what the main function is by describing what the ugly part is. And when I describe what the ugly part is, I end up with a guessed link on the chain. And then I can get rid of that simply by replacing it with du. So essentially, I'm deleting this. Because if I want to go backwards from the answer to the original function, I have to figure out what the chain is, and I just have to make it disappear. Okay? So that's what we're doing. All right, so function is a little easier than the explanation, so we're just going to play a little bit here. So take a look at the next one. Let's try it out. I'll do it in just a moment. Go ahead and pause it, and as soon as you're either frustrated or you got it, go ahead and hit play. All right, so I have the integral of 5x squared plus 1 squared times 10x dx. What's the ugly part? The ugly part is this stuff inside of the square. So I'm going to set u equal to 5x squared plus 1. That means that du is equal to 10x. The derivative with respect to x is equal to 10x. For notation purposes, I move the dx over to the other side. Is there any way I can make a 10x dx? Well, I've got it sitting right here, right? So I'm going to replace this with the integral of 5x squared plus 1 is my u. So u squared, I'm replacing this with u. And then I've got 10x dx. 10x dx is this. So I replace that with du. And I get u to the third over 3 plus c. Then I remember that's going to be, I replace the u with 5x squared plus 1 cubed, 1/3 out in front, plus c, and that's how we do u substitution. All right? Go ahead and try the next one. It's got a little glitch to it. Try it out, and when you get frustrated or you're done, hit play, and we will do it. All right. X squared plus 1 dx squared, right? So take a look at this and go, all right, ugly part is going to be x squared plus 1. Du therefore equals 2x. Lay dx down here, move the dx over to the other side, 2x dx. Do I have a 2x? No, I'm missing my 2x. I've got an integral, I've got an x squared plus 1 squared. I've got an x dx. I really want a 2 right here. And I don't have one. So I'm going to put one there. When I put a 2 there, though, I'm cheating, right? I need to change out. So what can I multiply the 2 by to make it go away? Well, 2 times 1/2 is 1, and we go away. So I'm going to multiply by 1/2, right? Now, if I do that, unfortunately, I got a 1/2 in this messy spot in the middle. So what I can do is I can take the 1/2 and just throw it out in front because it's multiplied, right? End up with x squared plus 1 squared times 2x dx. Now I've got everything in terms of u inside. I go 1/2 integral u squared du. Raise this power by 1. Divide by the power I get. Plus c. I got 1/6. I got x squared plus 1 cubed plus c. Okay, so what I do that's different. I looked at this and I said, well, all right, I didn't have the 2x, so I made it. And as long as it's a constant, I can multiply a constant inside, divide by the same constant outside, and then I can continue with the problem. All right. All right. I'm going to try problem number 7. Pause. Okay, so this is the integral of 1 plus 2x to the 4th power times 2 dx. Okay, so the ugly part looks to me like it's going to be 1 plus 2x. So that's going to be 1 plus 2x. Du equals 2. Now, I've been putting the dx down here because that's what we're really doing. But after we've done about 1,000 of these things, we get a little bored of that. So we're just going to throw the dx over here just right away. Do I have a 2 dx in the problem? Yes, that means I did it the correct way. So now I can go integral, getting ready to u it. That's u, everything's ready to go. So I'm going to go u to the 4th du, right? Replacing 1 plus 2x with u, and replacing 2x with du. I get u to the 5th, 1/5 out front, plus c, 1/5 u, 1 plus 2x, put it back in to the 5th power, plus c, and that's my final answer. All right. Alrighty then. Okay, go ahead and do 9, and then go ahead and do 11. I will do number 11 with you in just a moment. All right. And that was number 7. Okay, you should have already done 9. This is 11. Let's do 11. Integral of x to the 3rd of x to the 4th plus 3 squared dx. And so I say u has to be equal to x to the 4th plus 3. So du has to be equal to 4x to the 3rd. Now it goes away and I tack on the dx. Again, dx technically goes down here, but we always move it over here, so why not just go ahead and move it? So I line this up. I got an integral. I got my x to the 4th plus 3 squared. Then I look and go, wait a second, that's not working. Then I realize I got it hanging off the back. I get x to the 3rd dx. So I'm close. I need a 4. I don't have a 4. So I'm going to make a 4. I can't just throw 4 inside, so I throw 1/4 out in front just to cancel that out. Now this won't work for x's, right? So if I wanted to put in a 4x, right, if this was x to the second, I need to add another x. I can't do that, right? Because I can't pull an x out of an integral sign without changing what's going on, right? The integral ignores constants, but it does not ignore x's, right? So that would be a problem. All right, so moving forward, I get 1/4, the integral x, I get u to the second, du, everything's ready to go. This becomes u to the third, 1/4 out in front, plus c, that's 1/12. What was u? U was x to the fourth plus 3. Tack on 3 here, plus the c, and I am done. All right, finish this worksheet for homework, and I will see you on, what would it be, Tuesday when we get back. All right.